Hello everyone. In this session, we will discuss about the signal flow graphs. Signal flow graphs is also a representation of a system and it is useful for to find out the transfer function of the system. So whenever we are finding the transfer function, automatically it will give the system characteristics. That means system input, system outputs, how the input is modified from input to the output, that will be represented by the signal flow graphs. The another method is there is a block diagram method is there, that is also representing the system, right? So signal flow graph has some characteristics in that it is a graphical representation. It's look like a graphical representation, okay, of the relation between the variables. So we have the different variables. Variables means we have input and output, and branch elements. So that will give the representation. It is graphically displays the transmission of signals through the system. So it will represent in terms of signals. For example, we have a input and output is there. For example, R of S is input, C of S is output. Then the signal will be represented like this. For example, G of S as the transfer function. Then automatically input is transferred to output through the branch G of S, that is represented like this. Okay, that is represents like this. So in signal flow graph we have some terminology, that is the first is the node. Node means it represents the system variable. For example, one signal flow graph is like this: A, B, C, D. These are the nodes. It has the path. It may be the input and it may be the output. So these points are called as the nodes. A, B, C, D are called as the nodes. These represent the system variable, and that may be, it may be the input or it may be the output, or between input and output variables, like that. Next, input or source node. In that node, particularly if we get input node means it has only outgoing branches. So look at here. So for example, we have different are there. This, it has only outgoing branches. Look at here, this is the A has only the outgoing branch, it doesn't have any incoming branch. Then A is called as the input node or source node. Input means which will give, source also which will give, that's why A is called the input node. Second, output node or sink node. Output means receiving node, sink node also receiving, it has only incoming branches. So look at here, B has incoming and outgoing, C has incoming and outgoing, but what about D? D has only the incoming branch only, that's why D called the output node or source node. Output node or the source node. Next, path. It is continuous traversal of the connected branches in the direction of the branch arrows. Look at here. For this particular signal flow graph, if you observe here, so once again we will redraw this. So if you redraw this, for example, same thing, we have a and the B and the C and the D. Also we have the E. Path means, so the signal flow graph has variables like this. Path means it is which is input for this. A is the input for this signal flow graph, E is the output for this signal flow graph. Why? It has only outgoing branch, E has only the incoming branch. What is the path? For example, path is 1, path is, for example, G, H, I, J, like that. Then the path is called as GHIJ. GHIJ is called as the path. Path means it represents the gain here. These signals are nothing but the gains. G is the gain between A and B. H is the gain between B and C. I is the gain between C and D. J is the gain between D and A. Like that. Path gain. Product of the branch gains of particular path. So same thing here. Here path gains means so we have, for example, if you take the A, B, C, G and H, this is the input and this is the output. Then we have only one path is from input, path is A, B, C. What is path gain? Now we will tell the path gain is, so this is called gain between A and B, H is called gain between B and C. The product of G and H will give the path gain of the particular signal flow graph. So this is the path gain. Next, what is the loop? The path which originates and terminates at the same node along with the no other node is encountered more than once. For example, we have another branch, take it like this, A, B, C, D and E like this, and we have one branch is called like this. So the path is A, B, C, D, E, and look at here, if you observe between B, B to C, C to D, D to E, this is called the loop. This is called the loop. Understand? Loop, the path which originates, look at here, which originates and terminates at the same node, look at here, and end at the same node, that means at the B node only. Along another, no other node is encountered more than once. Look at here, in this B is available only one time, C also, D also is available only one time. That is called, it is called as the loop. Okay, loop gain, product of the branch gains of the loop. So for example, we have branch gain, this is 1, this is 2 and this is 3. Then the loop gain is, we can take the loop gain value is 1 into 2 into 3. Then loop gain value is become 6. So loop gain value is become 6. Right, this is called the loop gain. And what is the self loop? Loop consisting of the single loop. For this example, simply, so we have a signal flow graph is like this, A, B, and C, and for example, it has only one loop like this, it has some minus G, A, B and C. A, B, C are the variables. This loop, this minus G loop is called as the self loop. The loop consisting of the single node, or single, better to take not single loop, or the single node, is called as the self loop. This is called as the self loop. So these are the different terms available in the signal flow graph. So before entering into the problems, first the signal flow graph means simply represents like this. So for example, A, B, C are there. A, B, C are the variables, that may be input or output, anything, input or output, like that. So we have some gains as available, for example G and H. These are the transfer functions, we can name it as, these are the gains, or the another name is the transfer functions. Another name is the transfer functions. Okay, so this is about the signal flow graph. So we can represent the system in the form of the signal flow graphs also. So when we are discussing one problem, you will clearly understand what is the signal flow graph, how we are representing this system, and how we can find out the transfer function. So look at here, we have a one problem here. In this, look at the problem, find the transfer function of the below signal flow graph. So signal flow graph is like this. So here branches 1 2 3 4 5, and these are the gains 1 1 g1 and g2 g3 and 1, like that. So whenever the signal flow graph is like that, in order to find out the transfer function of this particular system, we have a formula. The formula is Mawson's gains formula. Mawson's gain formula. What it represents? It represents the system transfer function, that is summation of k equal to 1 to k pk into del k by del pk into del k by del. So in order to discuss each and everything, first we need to look at how many forward paths from input to outputs. First we need to look at the forward paths. Forward paths. What is the meaning of the forward path? Forward path is nothing but input to output path. So how many input output paths are available? Just look at here. Yeah. Here if you observe, assume that this is the input and this is the output. From this is the input, this is the output. Why it is input? It has only outgoing branch. Why it is output? It has only incoming branch. So here look at here, this is the one path. This is the one path. What is another path? And this is the second path. We have the two paths. This is the one path and this is the second path. So that's why we will take the paths. So path 1, take it as the P1. How we will get the P1? P1 is nothing but, in the forward path 1 you have to write the branch gains. So from between, first take it the 1 to 5 path, this path, in this write the branch gains. So in between 1 and 2 branch gain is 1, in between 2 and 3 branch gain is G1, in between 3 and 4 branch gain is G2, in between 4 and 5 branch gain is 1, then forward path 1 equal to G1 into G2. Next we should write the forward path 2. Look at here, forward path 2 is follows this dotted line. So here in between 1 and 2 the gain is 1, in between 2 and 4 the gain is G3, in between 4 and 5 gain is 1, then the forward path 2 is G3. G is D. So before that, and next we will find out the del. What is del? Del is the formula 1 minus sum of individual loop gains. Sum of individual, this gain we can write like this. Better to change the ink color. Individual loop, sum of individual loop gains and plus product of two non-touching loops. Non-touching loops minus product of three non-touching loops. It consisting of the product of three non-touching loops. So this is the formula. For that, 1 minus sum of individual loops. So where are the loops is there? First you have to write down the loops here. So I will write the loops. First, loop 1. Look at here. This is the, I can take, this is the loop 1. Look at here. This is the loop 1. What is the loop 1? Loop 1 is G1 into minus H1. Then you will get minus GH1 is the loop 1. And what is the loop 2? Here loop 2 is, so any other loop is there? This is not a loop. So another loop is minus H2. Minus H2 is the loop 2. So write it. Sum of individual loop. So loop first is minus GH1 is the loop 1 and minus H2 is the loop 2. Okay, this is 1 and minus into minus it become plus. What is next is, so next is better to take like this. This is minus and this is the plus and next is the minus. Okay, this is plus and product of no two non-touching loops. Observe here, this loop is non-touching to the this loop. These two loops are non-touching, so we can write product of two non-touching loops. So product means minus GH1 into minus H2 minus H2. Okay, so if you simplify this, you will get del value is like this, that is 1 minus or otherwise you can write directly. So better to take right. So if you simplify this, you will get GH1 plus H2 minus into minus become plus GH1 and H2. So this is the del of the given signal flow graph. So this is the del of the given signal flow graph. Yes, this is the given signal flow graph. So we have two loops, that's fine. We can extend the transfer function like this. So here the transfer function is, I can write like this, the transfer function is transfer function equal to P1 del 1 plus P2 del 2 by del. Okay, what is del 1? Del 1 equal to simply so this is del gain of loop non-touching to forward path 1, non-touching to P1. Del 2 is same gain of loop non-touching to forward path 2. So by using this del 1, so if you observe P1 here, if you observe P1, just forward path, this loop is touching and this loop is touching, so there is no, that's why we can write minus of, that's why we can write 1 minus, so complete 0, so del 1 value become the 1. P2 also, so P2 is like this, forward path is like this, it is also touching this loop and this loop, that's why I can write del 2 is like this, 1 minus again 0, so both are 0. So finally I can write the transfer function is like this, that is P1 value is G1 G2 and del 1 value is 1, P2 value is G3, del 2 value is also 1 by, so del value is G1 H1 plus H2 plus G1 H1 into H2. So by doing the simplification we will get finally same thing, so G1 G2 plus G3 by 1 plus G1 H1 plus H2 G1 H1 and H2. So this is the transfer function of the given signal flow graph. Transfer function of the given signal flow graph. Okay. This is the procedure to do the transfer function of given any signal flow graph. Okay, I think all of you understand this session. These signal flow graphs are very important, and these are the shortened form of the block diagrams. Okay, so it is very applicable more than the block diagrams. I hope all of you understand the session. Thank you.